Hey students, in previous lecture I discussed having clause. Today I will discuss nested subquery. When we write a query inside another query, that's called nested subquery. Nested subquery we used for set membership, set comparison and determining set cardinality. A subquery is a select from where expression that is nested within another query. When we are writing one query within another query, that's called as nested subquery. First, I will discuss set membership, then I will discuss set comparison. What is set membership? We need to check whether one set is member of another set or not. Let me explain this through an example. For this, we will use the in connective. The in connective test for set membership, where a set is a collection of value produced by a select clause. So we'll check whether this set of value present in another set of value or not. We can use in, not in, both. First I will discuss in, then we'll discuss not in. Find all course taught in both fall 2017 and spring 2018 semester. So first we will check all course taught in fall 2017. Then we will check same course also in spring 2018. We will use in connective here for checking set membership. Select distinct course ID from section where semester equals to fall and year equals to 2017 and course ID in. So that we need to check in spring 2018. So I'll write select distinct course ID from section where semester equals to spring, year equals to 2018. So it will show all the distinct course ID which are in both fall 2017 and spring 2018. Suppose 2018 course ID are X, Y, Z, P and 2017 fall course ID are X, Z. So we can say X, Z are in X, Z, Y, P. Hence X, Z are the course that taught in both fall 2017 and spring 2018 semester. The same way in test for set membership, not in test for the absence. Means some course which are absent in the other set. The not in connective test for the absence of set membership. Let's see this example. Find all course taught in fall 2017 semester but not in spring 2018 semester. So select distinct course ID from section where semester equals to fall and year equals to 2017 and course ID not in. Select course ID from section where semester equals to spring and year equals to 2018. Suppose here course ID are X, Y, Z, P, Q. Here let A, B, X, Y. Then it will display AB, not XY, as XY present in 2018 spring semester. So it will show all the course which taught in fall 2017 but not in spring 2018. XY are common in both. Rather than XY there is AB. It will show AB but not XY. We can write same query using except. Rather than not in, we can write except also. But here we are studying set membership. In, not in comes under set membership. Let's see another example. Name all instructor whose name is neither Mozart nor Einstein. So select distinct name from instructor relation. It will show all the distinct name from instructor relation where name is none of these two. Okay. So write where name not in, and this is a set. So in set we'll write Mozart and Einstein. Either you can write a query that will give his set as an output, or you can write direct. So here we write directly these two names. Let's see another example. Find the total number of students who have taken course section taught by the instructor with ID 10101. So select count distinct ID. We need to count total number of students taught by instructor ID 10101. That's a select count distinct ID. Maybe same student taught different time. That's why distinct ID. From text where course ID, section ID, semester, year, in. Then select course ID, section ID, semester, year from teachers, where teachers ID equals to 10101. It will count the number of students who are taught by instructor ID equals to 10101. Next is set comparison. Here we can compare two sets. For this we will use sum or all. In set membership we used in or not in. Now in set comparison we will use sum or all, like greater than equals to sum, less than equals to sum, greater than equals to all, like that. Let's see one example. Find name of instructor with salary greater than of some or at least one instructor in the biology department. That we can write as select distinct T name from instructor as T, instructor as S. We did rename instructor as T and instructor as S, and we'll compare T with S. So here T salary greater than S salary and S department name equals to biology. It will give all the instructor name whose salary is greater than at least one person salary of biology department instructor. This is one way of writing. I already discussed this type before. Now we'll do the set comparison, where in one set there will be all instructor, in another set there will be biology department instructor. Let's write the code that we can write by sum clause. So select name from instructor where salary greater than sum, then select salary from instructor where department name equals to biology. So it will select salary of instructor from biology department. Now this select name from instructor will show whose salary are greater than some instructor salary of biology department. SQL allow us less than sum, less than equals to sum, greater than equals to sum, equals to sum, or less than greater than sum comparison. Here we used greater than sum. Next, set comparison using all clause. So in place of sum we can write all. That means it should be greater than all salary of biology department. Now find the name of all instructor whose salary is greater than the salary of all instructor in the biology department. Here query will be same, just in place of sum we'll write all, because it is asking all instructor of biology department. So select name from instructor where salary greater than all. Select salary from instructor where department name equals to biology. Both query are same. Here just we write all, here is sum. Now according to first query, it will show output as 50k, 35k, 60k, as 35k is greater than 20k, and this is biology department instructor salary. Now according to this query, it will show only 50k, 60k, as in biology department there is an instructor whose salary is 40k. So SQL allow us using less than all, less than equals to all, greater than equals to all, equals to all, and less than greater than all comparison, like sum. Equal sum is identical to in, whereas less than greater than sum is not same as not in. Okay, understand the difference. Less than greater than all is identical to not in, but equal all is not same as in. So equal sum is same as in, and less than greater than all is same as not in. And any is similar to sum. In place of sum you can also write any. Earlier version of SQL uses any, but later version use sum and all. Let's see another example. Find the department that have the highest average salary. We need to find average salary of each department. Then we need to compare their average salary. So select department name from instructor, group by department name, having average salary greater than equals to all. Select average salary from instructor, group by department name. So what it will give as output, it will give average salary of each instructor group by department name. Suppose department name is A, average salary is 20k, B 30k, C it's 40k like that. So average salary group by department name. Now it will give the department name having highest average salary. So that will be C. So select department name from instructor group by department name having average salary greater than equals to all. So it will show the highest average salary. That's all for today. In today's lecture, I discussed nested subquery. There I discussed set membership and set comparison. In set membership, I discussed in, not in, whereas in set comparison, I discussed some and all. In next lecture, I will discuss the test for empty relationship. If today's lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.